All right, good morning, everyone. Did everyone have a good time last night? Everyone awake? Someone here sleeping? You're sleeping. Okay, cool. Right, so I'm going to talk about REST APIs. Who here has been working with a REST API a lot? Cool. Who hasn't been working with a REST API at all? Okay, cool. I'll try to make you get along. So, and then we have next question. Who here is getting stuck in a conversation about a REST API not being a true REST API? Okay, some of you. How many find that conversation really, really annoying and really unproductive? Because there's one thing that's really annoying, that there is really no true REST API. Roy Fielding himself posted a blog post about how people were doing it wrong, according to his view on how it should be done. A lot of people assume, oh, you need to do media types and whatnot, and etc. But the thing is that there's a failure in how you behave when you're approaching these kinds of API, because if you state that you have to do something in a specific way, then people will try to do that. And if those persons aren't really experienced enough to say, seriously, do we need all this? Then you're going to introduce a serious cost of that development, which could potentially be harmful for a company. So I think that it's important when you're given a rule to say that you have to use media types for this and that. Well, seriously, break the rules. That's important. Because breaking the rules leads you to know if you need that rule or not, right? But if you break the rules all the time without any structure, you get chaos. And if you get chaos in your code base, that's not really a good thing. So what I suggest instead is that you break the rules, but you do it in a structured way, in an effort to gain an effect, to reduce the amount of work that you need to do and try to get away with as little as possible. I mean, we're developers, we're lazy, that's what we're good at, right? So you need to try something new, try it out, and preferably you even fail. Right? This is important, this is when you learn. So if you tried something, you built a REST API and you didn't follow the rules and you failed, if you failed cheaply, if it hasn't gone into production or you noticed it early, then it's cool, it's no problem, right? And how do you fail cheaply? Well, you write less code to do it. The more code you write, the more time you invest in it. Also, if you have less code, you can just throw it away. If it took you 4 hours to write something, throw it away and write a new thing, try it out. And if you have more code, there's more code for bugs to hide in, right? You know, in a garden, bugs hide under the leaves. So why am I having this talk? I need to have a problem definition, right? There's something wrong with how we conventionally use REST APIs and build them, because everyone's doing the same thing. And I'm not saying it's wrong in all the scenarios, but we've noticed at my workplace some things that could potentially be improved. And to the more specific to the point, I'm going to talk about put operations. Right? A REST API has this concept that you have a resource, right? For example, here's a mock-up resource. I need to go buy milk. It's not done yet, but I can do it. I have a budget of 200 euros. Apparently, I need a lot of milk. And that resource, of course, has a URL where you can go and fetch it. And you can go and fetch it with a GET request, you can create it with a POST request, you can update it using a PUT request, and you can delete it with a DELETE request using a HTTP. But something gets really hard when you start talking about versioning a REST API. So say, for example, that you have a iOS client, something that's up on the App Store. no matter how fast you can develop your iOS client in production will be 1 month behind. 1 month behind is a long time. And that goes for most other stores as well. I'm not trying to track down on Apple, even though I have an Apple computer. So let's look at this put operation again. All right? Say I have my budget of 200 euros. But on my cell phone, I don't have an updated client, so it doesn't know about the whole budget thingy. It doesn't know about it. And it sends JSON. Potentially you can use XML, make sure it breaks, but then you have to handle that. But if you use JSON, it's going to be fine to send up something where a value is missing, right? But what happens with that 200 euro budget? Do I delete it? Does my old client lose data? That's not really good. Can I leave it? That could have its own problems. And this is perhaps not one of the largest problems you will have, but the solution to this could potentially mean that you add an if statement for each and every property on your model that you're sending up, the resource. So it would be nice if we could reduce the amount of things we need to do, right? Another problem is, what if you have multiple readers, multiple writers, right? So I have two persons who are working on the same resource. And one says, cool, I can go buy milk for 200 euros. Yes, I love milk. And the other says, no, seriously, we don't need 200 euros of milk. We just need 20 euros of milk. It's absurd. But what occurs if one person over said, cool, I'm going to go fetch milk. And the other says, no, no, no. You have a conflict, right? Now, if you're going to solve a conflict, you could add a lot of specialized code in your REST API saying, cool, you have a conflict. I'm going to return an error code saying that your data is old. Maybe, if I'm lucky, your REST API would tell me what's wrong. If not, then I just need to update. And potentially, you could lose data here as well, depending on how you handle that. And what usually happens is that you change your REST API to be specialized on writing instead of reading. So your clients, who will do mostly reading in most scenarios, suddenly need to adapt to a world where it's easier to write than read. And this is not really good. Or you just branch out your REST API with a lot of resources, some of them for writing and some of them for reading, and that means you increase your amount of code, you get the whole, this is not a true REST API conversation, which you're going to get anyway. So that's not really good. Another problem is bulk operations. Each and every resource in your REST API has a unique URL. You can do HTTP pipelining and stuff like that, but the problem still persists. You're going to do one HTTP request for each and every resource you wish to update. If you're on a cellular network with a cell phone, that's potentially even bad. And it turns out that it becomes quite slow if you need to update large amounts of data. It could take even days. And as your application grows, and you want to have webhooks, and you want it to be able to respond to changes in your application, maybe for some reason you want Runkeeper to be updated when you actually bought the milk. State changes, for example, if it's in progress, I can't change the budget. All this means you need to add code when you're updating your resource, and you're doing that in the code that handles the put operation. Everything gets put there, and you can do refactoring and model it out and potentially get a better put operation, but it's going to be problematic because the starting point is always the same place. There's no isolation of what you're doing. Right, I forgot to mention who I am. My name is Morten Nielsen. Some of you might know me for selling suits in Japan. My friends usually discuss whether or not this is a picture of me. We don't know yet. Maybe it's stolen, maybe it's not. That's my Twitter handle. You can also find it at the bottom corner of my slides all through the presentation in case you want to tweet me about something. That's my blog right there. That's what happens when you buy your domain name when you're 16. And also I'm on this dating site called GitHub. It doesn't really work out, but you know, if in case you want to hook up on GitHub, that's also my GitHub page. There's some stuff there that could be fun. So I work for a company called Remotex Technologies. I'm one of a team of currently 4, soon to be 5 superhero ninja developers. And I'm not just saying that because this is live streamed and at least 2 of them are watching. What we do is that we take cell phones and give them to handymen, plumbers, whatnot, and make sure they get all their work on the cell phone and report all the work on the cell phone. And that way we can streamline the entire administrative process around distributing work to people, getting charged, making sure that everything's in order when the invoice is sent, etc. We have customers that have their own armies of people taking care of vast amounts of buildings. We also have the super team of 2 plumbers and an administrative person doing like superhero work, need an awesome cool tool to do that. And this means that we have this handheld device. It's offline capable. It's written in HTML5. It's cool. You can listen to my talk about that sometime if you're lucky or unlucky, depending on how you see it. But every customer of us has their own system installation, which means versioning is actually an issue. So as you see the slide here, the cell phone actually talks to one system. And also we need to hook this up to invoicing software, maybe update some sort of web portal so they can notify their customers if they're coming or not. They need some business intelligence tracking if they're large. And so we need to write integrations to all different parts of systems. And every integration in itself is a client to our REST API, which means that if we upgrade our REST API, we have a versioning problem also on the backend side where we connect to all the other systems. Cool. So, last summer, I was having a good time, vacation. I do what you usually do on a summer, and that is to write offline clients. I was trying out a new method of writing data synchronization, basically because I was inspired by a blog post from a team who does a tool that we're using internally for our own administration of like the development process. It's called Pivotal Tracker. And they wrote about how it was built. And they had an MVC model and JavaScript and whatnot. But what I took away from that blog post was this, that they had a rich model on the client of what your domain looked like, which means they could see how everything is affected as they change things on the page. It's quite similar to our mobile cell phone client. You can see everything there. It's just, yeah. So I wanted to see if I could move some of the business logic into the client so that we could get a more rapid feedback. Also, I wanted to try things out. And in Stockholm, there's this huge movement doing CQRS. CQRS means you send events and you react to events, and you can do these streamlined and send message queues and whatnot. Also, you have an event store, and it becomes this huge architectural thingy, which is quite hard to grasp if you don't really take the time to do it. And I didn't really want to do all that. I was doing this for fun on my vacation, just to try things out. So what I took away instead was that I needed to separate my commands and my queries. So I wanted a model for writing and one model for reading, so that my reading model remains specialized for reading, and I send a command to do the writing. That was my idea. So the core concept here is command. And we start thinking about that. Well, everyone's talking about commands. Cool. What is a command? Who here uses Linux or Bash or PowerShell? Yeah. So for me, a command is you type a command into a command prompt and you give it some arguments saying what to do. So in a to-do list application, it would be, well, complete the task to 1, 2, 2, 3, something like that. Cool. Well, that's simple enough. That's a command, right? Well, let's make an endpoint where I can just post commands to it, see what happens, try it out somewhere safe. Okay. Well, it turns out that the complete task representation in this type is entirely version safe because it's tied to the domain, right? If I have a to-do list application, it will always have something to complete a task. And you say complete the task and you specify what it is. It's that simple. You don't have to send the entire task to the server. This is the new representation of the task. I have all the details here. Just say, no, this is done now. That's all you need. Another interesting thing with this was that I can send 2 tasks from different clients. Complete it, set the budget, and it won't conflict. The post endpoint, the commands endpoint, which I posted to, will just say, cool, I got the command, awesome. Maybe give an error if it fails, but this is sort of conflict safe, right? If I'm changing 2 different parts of the representation that won't conflict, then I don't have a conflict if I send just the parts that I need to change. Interesting. Well, another thing is that I can wrap these in a list in JavaScript. That's cool. But all of a sudden, I notice that this representation supports bulk operations, which is great. I can send up all the updates I need to do in just one chunk. And what's even greater is that this supports transactions. If anything fails in my chunk of stuff to do, I can leave the database intact, unmoved by the changes that I suggested that should be done, and report back an appropriate error message so the potential client could change. Cool. So what does the server-side implementation of a command look like? Well, I ended up with something like this. This is sort of faked for my domain model of buying milk. But the set budget command, it inherits from a command, and that makes sure that I can take in the properties or the parameters to the command. You can see here that this is, by the way, Ruby. But you can see I have a function here called parameters that specifies, well, the first parameter is the ID of the resource I'm updating. The second parameter is the budget that I'm setting it to. And when I execute it, I open a connection to the database. I fetch the resource I want to update. I set the budget value, and I'm happy. It just works. You can do things to handle depending on how you want your domain to react. So, for example, if there is no resource with that ID, you could easily, depending on your database, say there should be a resource with this ID. Make sure it's there and just set this value. Go ahead, go on. Or you could report back a failure saying, seriously, something's wrong. Testing. Let's look at the code again, right? How hard is it to unit test this code? Any ideas? 2. More values? 3? Anyone goes for 3? 1? Well, it's just one pass. You can get 100% code coverage by just issuing a single command to it. Done. This is completely isolated, very easy to set up. You can fake the database, depending on what tools you have appropriately. If you can't, then you can break that out to a separate process and fake that, and you can still do it, right? I had a client-side implementation. As I mentioned, the thing that I wanted to do was to have this rich domain model on the client so that you could see all the changes as you were doing them. And if you can see all the changes, notice that you don't have to post things back to the server at once. You can do that asynchronously. But you have the changes directly in the user interface. Super fast. Awesome. Similarly, move the slide there. I have a bunch of local commands. It's an object. I have a command name. I have a function that takes the arguments. And then I just get the tasks that need to be done, and I set the value I want to update. In this particular application, I use Backbone with its collections, so that the collection will signal that, oh, I changed the value, and any views that are listening to that in my application will automatically update. So all I had to do was just make sure that the value is changed. This is really cool. I was having a really good time implementing this all last summer. Sorry. So I get back to work. I'm like, woohoo, hallelujah, I come to save the situation, because I realized I could use these for these horrible integrations that were really hard to keep up to date with versioning. So I came back and I told my team of superhero ninja coders about what I've been doing all summer, and we thought, well, we could give it a try. I'm pointing there because the streaming camera's up there. We could try this locally at work to just see what happens. Could we do an integration using these things and sort of get an easier workplace? So we started out, said, cool, you do it, because I did it at home, and that way we share the experience and we can synchronize notes and everything like that. And we came up with a command structure that looked something like this. So instead of sending just a string, we send an object with a name of the command. In this case, it's called create case. I have a target, that's the ID. We'll create the case ID. And I have a bunch of parameters. I want the title to be this. I want the priority to be this. Does anyone here see any problems with this representation of a command? It looks like RPC so far. There is no, well, depends on. What's really interesting with this is that this becomes put all over again. It has the exact same properties on the code behind, or the server-side code, as a put operation. You have to have if checks to see if you submitted the values that you're going to update. You have to make a decision whether or not the values should be changed if you don't submit them. It has properties that an old client won't forget data, because you know that a new client is going to send an empty value on the parameters if you want to actually clear data. But it still has some good properties. You can still do transactions with this. You can still do bulk operations. You still have the versioning. Who said that versioning? Yeah, so it's still version safe. So this is actually still, for us, better than doing normal put operations. But we need to talk about what is a good command structure. What properties does a good command thingy have? And for me, one of the foremost things that a good command does is that it expresses an intent. So I've been doing some Android development because I play with cell phones. And you have this intent saying, I want to set the title of this, or I want to create this. Those intents expressed in your domain will always remain true. So even if you add new commands, the intent will still be there. An old client can still say, I want to create a new task with this title. Cool, do it. It's not a problem. Even if I have a create task version 2 for newer clients, it will still be, I will still in the domain be able to create a task with a title. Another good property of a command is item potency. Item potency is extremely powerful. So anyone here know what item potency is? Cool. Who doesn't know what item potency is? Seems some of you is awake. Awesome. Item potency is a property of a function. Say you apply a function, and it changes the value. If you apply that function again and the value remains the same, that function is idempotent. If you apply the function and the value changes again, it's not idempotent. So I'm going to give you an example. say I have the command structure that I have for at work. We created something called upsert case. We work with cases, sort of a job. Or upsert customer, perhaps, is a more general use case. I can have my client say, here, it's a customer. If this customer already exists, update it. If it doesn't exist, then create it with these values. Which means after I've committed this operation, if I send it again and nothing else changed, then nothing will happen. The customer will remain the same. And this is really good because all of a sudden you can be confident that you don't have to go up to the REST API to fetch the customer and see, have I added these values or not, and then submit a put operation. You can just send the command blindly and say, this is how it should look like, it's cool. Conflicts and commands. This is also something that becomes really interesting when you start implementing your commands. You can move the conflict handling from a scenario of doing HTTP and stuff, you can move that into working with your product. For example, changing the budget of a task that in progress should perhaps create some sort of alert, warnings and whatnot, or starting a task that maybe for some reason is flagged, then you can have systems in place to actually handle that in a way that your customers want it to be handled. Another good thing is if your commands are short and concise. If your command implementation is roughly the size of one screen, good, excellent. It's easy to test, easy to see what it does, easy to understand what the command issued will do in most cases. So some good stuff that happened when we started introducing this is that all of a sudden we could start using CSV and Excel for bulk operations, imports of data. When we get a new customer, here's an Excel sheet. Write down in the Excel sheet that what you want, which customers you want, and which values you want on which fields. And then we take that Excel sheet, make it to CSV, because we can read that easily in code. And we create a command for each and every one using the upsert customer command. And then we just post it up to the server, and voila, all our customers' data already in place. And we noticed this, that you can do this because we started doing integrations that send a lot of data in the bulk operations. And then we thought, oh, we can do this with Excel. And all of a sudden, the tools we have in place for our support technicians or the consultants selling the software out to our customers become much, much more powerful because it's faster. They can do it with the customer. Most customers knows Excel, that kind of stuff. Another really interesting, cool thing is that you get some sort of REPL system. If you can issue commands to your application, you can control it from a fake command line. You can make a small client that's just a command line. You can sit and hack commands to the clients, and it's really cool. If I have time, I hope to show you that later. But another thing is that it's really easy to set up tests. So you have a functional test. You need a customer or something in the system. You can just issue 5 commands. You know that these things are now in the database and which state they're in, because you can read the command list and actually see what's happening. And then you can make your assertion. So the setup of making a functional test all of a sudden becomes really, really easy. And then, of course, we have the really interesting property of offline. You can have your client update locally in your cell phone or iPad or maybe just your laptop in France and see all the changes. And as soon as your device gets connection to send up the list of commands, it just sends it to the server. And then you can handle however you want the feedback to the user to be. You can have, for example, a Outlook style outbox, or you could have a small icon saying, cool, everything is good. Server said it's good, no problem. And then we have this, push commands. Oh, I forgot to ask, how many saw the zombie code presentation just before. It was a really good presentation because it talked about publish and subscribe and event-driven architectures in JavaScript. And if you have this, you can actually push notifications out to your clients. So if they get the notification, they can directly update their UI to reflect the changes. That's all that's been done on the server. So when the server gets it, cool, I need to complete this task. Then it can push it out to all the devices that's interested in that task, and make sure that the devices are updated in real time, which is really cool. So you can use Socket.io for that. There's a company in San Francisco, it's called PubNub, which I've used for my examples. App Engine has some channel APIs similar to Socket.io, which you can use just to do some really interesting stuff, because all of a sudden you can push things to the client. So I'm reaching the end. I'm fairly on time. Excellent. But I want to give you some sort of conclusion, because one thing that's sort of annoys me is that most developers, when they hear of a cool new thing, they go back and say, we're going to do this. It's excellent. But I want you to give you the opportunity to have some sort of like, well, is this something to be used? So I want to talk a little bit of when to use this. And you can, of course, use this whenever you want, or whenever you don't want, or whatever. It doesn't really matter. But for me, offline, this is a really good way to do an offline client, because you can have things change in the UI instantly, and you can send it to the server. Some commands won't be able to reflect it on the client, but then you can make an informed decision of how you want to handle that. Maybe you want a small message saying, when this is synchronized to the server, you'll be notified. Another thing for me is the shared resources, right? It's extremely easy nowadays to pick up some tools, create a automatically created REST API, and you're up and going. And you'll be fine, conflict-wise, if your resources aren't shared between users. See, if I'm the only one using the to-do list application, then I will conflict with no one. So if your customer is updating a resource maybe once a year, then perhaps making an extra investment to do something larger just because there could be a conflict, maybe that could be handled by people talking to each other instead. Might be cheaper. But one thing that's really interesting is versioning of clients, especially when you go on market stores like App Store or the Play Store for Google or the Microsoft Place, whatever they call it. Just because you have this long period of time before your application is being accepted could mean that you need to have some sort of versioning model in place, and this actually works really well, at least as far as we noticed this far, and that's roughly a year of experience. But choose the model that suits you best. Only you know your domain and your problem, and only you know your customers. So that's fun. But you can have both if you want. You can have a command-based structure to make all your write operations, but you can still support the put operation. But if you do both, then let your put operations issue commands. So you get the model, you see what's changed, and then, because you have the database on the server, so that's fine, you can do that operation easily. And then you issue the commands needed for the changes. And that way you can sort of reduce the amount of code that you need to do to have both types of system implemented. So I mentioned that I did some Android development. I want to go back to intents. Because I found this tweet from, it's 4 years old, I think. And I found it recently because Google is shutting down Google Boss, and I got an email, and it's like, here's your old tweets. And I retweeted this a few years back. And one of the beauties of the Android architecture is the intent system, because you can inject things. You can change the implementation of what you want to happen. But the person who issued the intent won't have to notice that. It's modular, it's decoupled. And if we could have that in the web, we could, for example, have, well, this is a new to-do task when I click the button, then I issue an intent to create a new task in whatever to-do application I have. But we don't really care. But this is sort of a start there, for me at least, I think. Right. So I'm fairly on time. Anyone want to see a demo of the publish subscribe thingy? I usually fail at this, but I have some time, so I can try it. Who wants to see it? Who doesn't want to see it? Okay, cool. We're going to do it. Let's see if I can get Keynote to work. You see everything? There's my talk. Awesome. Do you see my mouse pointer? Here it is. This is actually a to-do application which I wrote to do basically this. So I have some tasks set up. You can see here that I'm logged in to the to-do application on 2 windows on the side. And then I have this window which I will try and issue commands to. But I can't really see what I'm doing, so it'll be great. And every task here has an ID. We're going to steal it because I did this earlier. Whoop. There. All right, so I have this. I'm not allowed to type. There. Done. This is with there. This is with the offline. I wanted to execute a command. And this is where I usually do wrong. There. And it's a list of commands that I want to issue. I want to tell it to complete a task. Oh, I cheated. Awesome. There. You notice? It changed the UI directly. There was also an icon up at the top saying, well, I have some changes, but it's waiting for more because it wants to send the biggest chunk of commands up to the server as possible in case I'm offline. Right. And then you can see all of a sudden when it reaches the server informs all the other clients, cool, this is completed. And in real time, the user interface for all the other users is updated that this task is completed. Did you see it? Should I do it again? I can do it the other way. I can decomplete the task. I actually added this command just so that I could see things going back and forth between the clients because it was fun. There, that one's decompleted. It's sending to the server. At some point, the other clients will be updated. 3, 2, 1. Oh, I don't have patience with this. There. It goes there. So it's quite fun to see that you can actually spread knowledge out to all your clients, even if you're on a web page, and just push it out there. This is done with the PubNub team, which is an interesting product because you don't have to set everything up yourself, but you can do it with Socket.io and everything. I have 5 minutes, but I'm going to go back to the slide anyway. Here we go, because I have a feedback slide. So I'm Morten, this is my name, you have my Twitter handle there. But I also have this feedback form, it's a Google form. So if you want to give me feedback, I have suggestions for things I should mention or shouldn't mention. You can go into the forum, the URL there, I added a QR code. I apologize for it being black. It would have been prettier white, but apparently QR codes can't really be accessed if they don't have enough contrast, and that's what happened. And I'm going to leave this up and open up for questions. Any questions? You don't set a version of your command. You make sure your command is version independent. That's what I would suggest. Otherwise, you could have a versioning system either on that your URL has the version number in it, or you add different commands as you go on. And then remove the ones when you're sure that the old clients are dead. The command model is only for write operations, that's correct. And for read operations, REST APIs are cacheable. With the web cache, they're a lot faster if you can have your model specifically designed for reading, which means you have a lot better performance when you're fetching data from the server. For reading? Yes, then you would have to either put it in the URL or you can put it in a header in the HTTP request, depending on how you want to implement it. Those are the two options I would suggest now, currently. Any more? All right, cool. Then I'm finished. Thank you.